and then we'll quickly go through what we have. Today we're looking at inductive reasoning. In our last class, we talked about deductive reasoning. We said the relationship between the premises and the conclusion is logical, and that, like mathematics, the meanings of the contents don't matter. What matters is the relationship. So you can have a valid argument that is not true because the information is not true. So whether the argument is true or false, it doesn't prevent it from being valid. On the other hand, for inductive reasoning, the relationship is not logical. It's possible to affirm all the premises and deny the conclusion without contradiction, because the premises are capable of producing more than one conclusion. So the example we saw in our last class of an inductive argument, 95% of men are honest, Peter is honest, therefore Peter is a man, therefore Peter is honest. We said Peter, it's also possible that Peter is not honest. So in the case of an inductive argument, it is not the structure of the sentence that tells you whether the argument is worthy of acceptance. It is you need to look at the meanings of the contents and then use your common sense to determine whether an inductive argument is close enough to the truth. So for inductive arguments, premises provide reason for believing in the likelihood of the conclusion, but the premises don't guarantee the conclusion. So inductive arguments are probability arguments. Because inductive arguments do not depend on rules, they are harder to evaluate. So because inductive arguments produce multiplicity of conclusions, it takes more homework to evaluate them and decide whether they are credible enough. Now, we have a distinction between verifiable and confirmable statements. Verifiable statements are statements we can directly test or verify. They are usually factual or empirical statements. Example, Kofi lost strength with age, so you can verify this statement. But on the other hand, we have confirmable statements, statements that we cannot test or verify directly, except through verifiable statements. Example, all men lose strength with age. So you use statements like Kofi lose strength with age to test the statement all men lose strength with age. Now we have a combination of them. The premises are verifiable statements. The conclusion is a confirmable statement. Kofi lost strength with age, Peter lost strength with age, and so on. Therefore, all men lose strength with age. So the premises are verifiable. The conclusion is confirmable. Another example, Mary reached menopause by 40. Grace reached menopause by 35. Meredith reached menopause by 33, and so on. Therefore, half of all women will reach menopause by 35. So you notice the premises are verifiable statements. The conclusion is not a verifiable statement, it's a confirmable statement. How do you detect confirmable statements? First of all, confirmable statements are not directly testable or verifiable. But the second way is that they can be converted into conditional statements. So, if you're able to convert a statement from a categorical statement to a conditional statement, then it is a confirmable statement. Example, no leader steps down from power unless compelled by a coup or constitution. Now, to translate it to a conditional, if X is a leader, then X will not step down unless compelled by a coup or constitution. Now, remember our distinction between finite and infinite reference classes. The finite reference class is a class of countable items. Examples, this copper, that man, some boys, that table, and so on. Then the infinite reference class is the class of uncountable items. Example, all metals, all men, all voters, and so on. Now we need that distinction here. We talked about confirmable statements. Now, confirmable statements or the conclusions of inductive arguments are normally hypotheses. So when you see the conclusion of an inductive argument, it's a hypothesis. And there are two kinds of hypotheses. You have the law-like and you have the statistical. The law-like hypotheses are confirmable statements that refer to all members of a class. So they use the infinite reference class. So those confirmable statements that use infinite reference class, they are law-like. Example, all metals expand when heated. The conditional translation, if X is a metal, then X will expand when heated. So, and then another example, all Fs are Gs. If each F is a G, no Fs are Gs, all Fs are not Gs. So statements that refer to all, none. So they are law-like. We call them law-like because they are referring to all members. Now, when you refer something to all members, then it means that any member in that class must have that quality. That's kind of law-like. Statements that don't refer to all members, like statements that refer to some, a certain percentage, and so on, they don't have that law-like capacity, because when you identify something as a member of that class, then you don't know whether it actually has that quality. So law-like hypotheses are highly predictive. G must be attributed or not attributed to every F. All men are mortal. If Peter is a man, then Peter is mortal. Anything that is a man is very predictably mortal. Okay, then you have the statistical hypothesis. These are confirmable statements referring to some percentage less than 100% and more than 0%. Example, 90% of those who ate the food fell sick, 90%. But you have other statistical terms. Apart from 90%, you can say some, few, many, most, hardly any, and so on. They are all statistical terms. Now, statistical hypotheses are less predictive. If 90% of the food, you said 90% of the food, those who ate the food fell sick. If X ate the food, then X, is likely to fall sick. 90% chance of falling sick. If 100% of those who ate the food fell sick, then you can say that an X ate the food. You can say X surely fell sick. That's a law-like hypothesis. But for statistical, if you say 90% of those who ate the food fell sick, and you say X ate the food, then X has only 90% chances of falling sick. That's why we say that law-like hypotheses are more predictable compared to statistical hypotheses. Law-like refer to 100% or 0%. Statistical refers to anything less than 100. Now, confirmation versus proof. Inductive arguments aim at confirmation. Now, confirmation does not mean the confirmation the way we use it in ordinary language. Confirmation here is not as strong as proof or guarantee. Confirmation is less than that, is weaker than that. So inductive arguments are aimed at confirmation. Deductive arguments are aimed at proof. Another name for deductive arguments are deductive proofs. Any deductive argument that is valid is called a deductive proof. So modus ponens is a deductive proof. Modus tollens is a deductive proof. Hypothetical syllogism is a deductive proof. Disjunctive syllogism is a deductive proof. So confirmation is not proof. Now the confirmation that inductive arguments aim at is not as strong as proof, the proof we see in deductive arguments. And then another issue, evidence also doesn't have all the power of proving something. Now, evidence itself is limited. In ordinary life, we think that evidence is enough to prove something. But in science, evidence itself has limitations. We're going to see that soon when we see the two types of inductive arguments. Now, how do you detect inductive arguments? There are two major ways to detect inductive arguments. The first one is that they are capable of more than one conclusion. We already know that 90% of those who ate the food fell sick. Amma ate the food. You have two conclusions. You have Amma fell sick, you have Amma did not fall sick. So that's the first way to detect inductive arguments. But there is a second way. The second way is that inductive arguments are extrapolations. They are extrapolations. An extrapolation is an activity that smuggles in information into the conclusion that is absent in any of the premises. So when you look at an inductive argument, you see that the conclusion contains an information that is not in any of the premises. Of course, you saw from deductive in deductive arguments that a deductive argument is simply deducing a conclusion from the premises. So any information in the conclusion of a deductive argument is already in the premises. And it is only the materials in the premises that you use in building the conclusion in a deductive argument. But when you look at an inductive argument, you see some information in the conclusion that is not in any of the premises. So we'll soon see how that is. Now, we said an extrapolation is an activity that smuggles in information into the conclusion that is absent in any of the premises. Now, all inductive conclusions contain information that is not accounted in the premises. Now, look at this. This is the technicality that explains it. And this is how an inductive argument runs. A known thing A has certain properties such as X, Y, and Z. Another thing B that is not in the premises has the same properties X, Y, and Z. Now, A also has an additional property Q. Now, on the basis of the above three premises, the argument concludes, in reality extrapolates, that B also has the additional property Q. So an inductive argument says that because two things, A and B, have three identical properties, X, Y, and Z. If you notice that A also has a property you have not seen in B, which is Q, then you conclude that because A already has the same properties, X, Y, and Z with B, B could also have Q because you notice Q in A. So the idea of induction is that if B is like A in some respects, B may also be like A in other respects. But you know that that is not a guaranteed argument. That argument is not foul-proof. Now, there are different directions of extrapolation. Just a minute. Now, so we had said that an inductive argument is an extrapolation. There are different directions that you can extrapolate. So I'm trying to show you different structures of inductive arguments. Now you have part-whole extrapolations. That is attributing something to a whole that constitutes a part or parts. We have two types. We have generalizations and we have statistical syllogisms. Now, in generalization, Peter is strong, James is strong, therefore all men are strong. Peter is strong, James is strong, all men are strong. So you are extrapolating from Peter and James to all men. Now, a quality that two men has, you would conclude that all men have it. That's a generalization. Then we have statistical syllogisms. Most Canadian university students drink alcohol. Caroline is a Canadian university student, therefore Caroline drinks alcohol. So we already saw this argument before. 95% of men are honest and decent, or 90% of those who ate the food fell sick. Now, so you see that this is a statistical syllogism because Caroline may drink alcohol, Caroline may not drink alcohol. Then we have analogies, arguing that something possesses the same thing as another because they both possess some other properties. Example, the structural adjustment program was good for Cameroon, which is a third world country. The structural adjustment program was good for Uganda, which is a third world country. The structural adjustment program was good for Senegal, which is a third world country. The structural adjustment program was good for Nigeria, which is a third world country. Therefore, the structural adjustment program must be good for Togo, which is a third world country. So you see that this argument is an argument by analogy. Now, the argument is based on the fact that these countries share a common property, which is third world countries. And then just because these countries share a common property, the argument assumes that something that works in some of the countries will also work in the others. It's just like saying Peter is 6 feet tall, Paul is 6 feet tall. Last week, Peter married a tall woman. Therefore, Paul is going to marry a tall woman. But you know that kind of argument is not very tight. Then we have predictions, attributing a quality to a future event because of the level of frequency of past occurrences of the same quality in similar events. Tyson has won his last 30 boxing fights. Therefore, Tyson will win his next boxing fight. So basing on a particular occurrence in the past to make predictions about the future. But you know that Tyson can lose his next boxing fights in spite of the fact that he has won the last 30 boxing fights. So prediction is another form of inductive arguments. So the inductive arguments, you have part-whole generalizations, which you saw is not a very good argument. You have analogies, which is also not tight. You have predictions. So all these arguments, they don't provide you guarantees of correctness. Now let's look at two kinds of inductive arguments based on their strength. So by strength, we mean their closeness to being correct. So enumerative inductive arguments. An enumerative argument is an argument with many premises, enumerating the premises like a list. So the first kind of inductive argument is the one with law-like hypothesis as conclusion. The second one is the one with statistical hypothesis as conclusion. So let's look at the first one. Now, this is an argument with 10 premises. It is an experiment to see whether metal expands by heating it up. So gold expanded when heated, silver expanded when heated, bronze expanded when heated, copper expanded when heated, and so on. 10 different metals expanded when heated. And then the summary premise tells you all the metals tested so far expanded when heated. Then the conclusion tells you, okay, all metals expand when heated. Now, you will notice that there's a difference between the premises and the conclusion. The premises are particular statements. They are verifiable statements, particular statements. The conclusion is a general statement. Even the summary of the premises says all the metals tested so far. So it's still a particular statement, but the conclusion is a general statement. Remember, I was telling you that all the men is not the same as all men. All the men can be counted. All the men in this class, all the men in this university, all the men in this town, and so on, all the men in this country. They are countable, but all men cannot be counted. So this argument moves from premises that are particular statements to conclusion that's a general statement. It moves from premises about countable items to a conclusion about uncountable items. So there is an information that is in the conclusion that is absent in the premises. The premises do not provide you any information about the infinite reference class or about members of an infinite reference class, but you see the infinite reference class in the conclusion. So that's an information that is not in the premises. That's why we said inductive arguments contain premises that inductive arguments, the conclusions of inductive arguments contain information that is not in any of the premises. So that's why inductive arguments are not valid. They cannot be valid because some information in the conclusion is not accounted for in the premises. Now, this is a technicality. Premises 1 to 10 are verifiable or particular statements. The summary premise is a summation of all the verifiable premises. But then the conclusion is a confirmable or general statement. So the argument is strictly invalid because it involves jumping from verifiable to confirmable statements. That's the reason why confirmation is not proof and inductive arguments are not valid. And then another problem you see with this argument is the limitation of evidence. Now, gold expanded when heated. That's an evidence. Silver expanded when heated. That's an evidence. But these 10 pieces of evidence are not enough to prove a general statement, Okay. So, in fact, the conclusion is false. All metals expand when heated is a false conclusion, as it turns out, because some metals, in fact, do not expand when heated. They are called superconductors. They don't absorb heat, so they cannot expand. So the conclusion is false, and all the premises are true. That's why we say it is possible to deny a conclusion with all true premises, and it is possible to affirm premises and deny conclusion. And this is applicable to all the types of extrapolation, part whole, analogies, predictions. They can have true premises and false conclusions without any contradiction. You can say, for the generalization, we saw Peter is strong, James is strong, all men are strong. So you can say Peter is strong, James is strong, all men are not strong, or not all men are strong. That's also correct. Then for analogy, we saw structural adjustment program was good in Senegal, Nigeria, but it was not good in Togo. So that argument is also correct without contradiction. Then for prediction, we saw Tyson won his last 30 boxing fights. So Tyson win his next boxing fight. It's also possible to say Tyson won his last 30 boxing fights, but Tyson will not win his next boxing fight. That's also correct without any contradiction. So inductive arguments, you can have positive premises and negative conclusion without any contradiction. That's how you know it's an inductive argument. Now, so that's that. We finished looking at inductive arguments. Now we want to compare inductive arguments with deductive arguments. We want to see how inductive arguments are in comparison to deductive arguments, the disadvantages of each, or rather you say the advantages and disadvantages of each. Now, deductive arguments are accurate at the expense of the inability. Now, before I start saying this one, by now you already know that deductive arguments are accurate. They are more accurate compared to inductive arguments. So that one is obvious. But what you don't know is that deductive arguments are accurate at the expense of the inability to provide information. So for examples, look at this disjunctive statement. Either it is raining or it is not raining. We know this kind of statement from disjunctive syllogism. Either it is raining or it is not raining. Now, this statement will always be correct. You cannot falsify this statement. If it is raining, the statement is correct. If it is not raining, the statement is correct. So whether it is raining or not, this statement is correct, statement one. But does it tell you whether it is actually raining? No, it doesn't. So the statement is correct at the expense of being able to provide information. And statement two is also like that. If it is raining, then someone will get wet. So this kind of conditional statement, we saw it in deductive argument. If it is raining, someone will get wet. So this statement will always be correct. It can never be wrong. If it is raining, then someone will get wet. If it is not raining, someone will not get wet unless someone gets wet through another means. So whether it is raining or not, statement 2 will always be correct. But does it tell you anything about whether it is raining? No. It doesn't tell you it is raining. So you don't really gain any information from it. So that's why we say that deductive arguments are accurate at the expense of being able to provide information. On the other hand, inductive arguments provide information at the expense of accuracy. So the disadvantage of inductive argument is the advantage of inductive argument. And then the advantage of deductive argument is the disadvantage of inductive argument. In fact, the advantage of one is the disadvantage of the other. Inductive arguments provide information at the expense of accuracy. Now, when you provide information, the information you have provided is falsifiable. We say it is falsifiable. Example, it is raining right now. When you say it is raining right now, you have provided tangible information. If you say it is raining right now, then I will know whether I should leave my house or not. I can go and get an umbrella, because if you didn't tell me, I might not use umbrella, and then I could get beaten by the rain. So the information it is raining right now is a valuable information. It will help humanity to take a lot of actions, take a lot of decisions, take a lot of measures because it is raining. Even it can help farmers. If it is raining right now, then some farmers will say, okay, tomorrow morning I'll start cultivating the soil because the soil will be wet. So, those things. So it's a tangible information. It will help in a way that deductive statements cannot help. But it is also falsifiable. It is falsifiable because it is providing tangible information. Any statement that provides tangible information is falsifiable. So the statement it is raining right now is falsifiable. Because if it is not raining, then it is false. And right now, it is not raining around my house. So for me, the statement is false. If it is not raining at where you are right now, then it is also false for you. So it is falsifiable because it is a tangible piece of information. Falsifiability and science. Any valuable empirical information must be falsifiable. Any statement that is not falsifiable cannot be a verifiable or confirmable statement. Any statement that is absolutely true has no empirical content. You saw those deductive statements. And then the more valuable the information, the more falsifiable. So the more valuable the information provided by the statement, the more falsifiable the statement. Now, the empirical statement, it rains every third Friday of the month, is more valuable information than it rained just now. If you say it rained just now, then a lot of people can take decisions about today. But if you say it rains every third Friday of the month, then people can take decisions about every third Friday of the month. So that means the statement it rains every third Friday of the month has more valuable information, or it's more valuable information than it rained just now, because it will cause more changes. But the more valuable the information, the more falsifiable. So it will take only 1/3 Friday of not raining to falsify that statement. Now, so let's look at the second type of inductive argument, arguments with statistical hypotheses as their conclusions. This is an example. Michael was vaccinated. Now, this is an example about people who were vaccinated to stop suffering from an infection. The vaccination was successful for some, but it wasn't successful for others. Now, Michael was vaccinated for polio and never suffered polio. Gilbert was vaccinated for polio and suffered polio. Mary was vaccinated for polio and never suffered. Stanley was vaccinated and suffered. James was vaccinated and never suffered. Bob suffered it. Jill didn't suffer it. Samuel didn't suffer. John didn't suffer. Carol didn't suffer. So the summary premise says that 8 out of 10 people who were vaccinated for polio did not suffer polio. So it means that 10 people were vaccinated, 8 did not suffer it, 2 still suffered it. So the conclusion is that polio vaccination has 80% potential of preventing polio. Now, 8 out of 10 people is 80%. So that's why the conclusion is that this vaccination has 80% potential of preventing polio. Now, the conclusion is a statistical hypothesis. A statistical hypothesis. So you can compare it to the law-like hypothesis, all metals expand when heated. Now you can see that a statistical hypothesis is better than general law-like hypothesis, because statistical hypothesis it is safer to defend, compared to law-like hypothesis. So now we have 2 types of inductive arguments. We have the ones ending with law-like hypothesis as conclusions, and then we have the ones ending with statistical hypothesis as conclusions. Now, hypotheses are technically regarded as conclusions of inductive arguments because they are confirmable statements to be supported, confirmed, or denied by verifiable statements. So this is the end of the class. Next week, we'll look at causal reasoning, and I hope you watch the videos and read your textbooks, do the exercises very well. Now we're going to take some questions. Anyone who has questions can ask, and then we'll address the questions. After that, I would close the class, upload the video to your Sakai immediately, and then all those who didn't attend the class, and even those who attended it, can watch the videos as often as they want. So any questions? Okay, so if there are no questions, I'm going to end the class right now. Today is Wednesday, so we'll be meeting on Friday again for causal reasoning. Owusu Mensa, did you want to ask something? So we meet on Friday, and then we...
Thursday.
No, we don't meet on Thursday, we meet on Friday. This is Wednesday.
Oh, okay.
Yes, by the same time of the day. Okay, so I'm going to end the class, and then I wish all of you the best.
Please, question.
Yes, you have a
Hello,
question?
sir. Yes, please.
Go ahead.
Sir, please, concerning the I,
Yeah.
the statements. During the lectures, we have 5 major types of statements. The emotive expressions, declarative, interrogative.
Yeah, just go ahead. I know them. So, what's the
sentence fragment, and yeah. So taking something like water is the basis of life.
Yeah, go ahead.
And you are to choose what type of statement is this. Will you say it's a declarative sentence, or you specify the particular type of declarative sentence?
Yeah, but did I ask something like that about declaratives?
No, please.
Yeah, so if you say it's a declarative, well, I can give you the full marks, or I can give you some of the marks depending. So you're supposed to.
So are we to specify it? Maybe it is a declarative, and you put it into a bracket like factual statement.
Yeah, you can do that.
Or you can do that.
Yeah, you can do that.
Thank you very much. All right.
Apart from being a declarative, you are supposed to know the type of declarative.
Okay. Okay. Thanks very much.
All right.
Say, I want to ask a question. So if it is a definition, so you are going to state.
Yes, so if it is a definition, how else did you want to state it? Okay. So that's it. And I hope you've done your assignments. The next one is coming soon. Remember to do those assignments in the early hours of the morning. No, sorry, in the middle of the night, between 12 to 2 a.m., so that you don't complain to me about network. All right, so watch the videos beginning from a few minutes from now and until our next class. All right, goodbye.
Bye.